So, hello everybody.
Yay, perfect. That's
Do you hear me well?
Yes.
Great. Sorry, I caught a cold, so my voice is not very good today. Hope you excuse me if I take some break sometimes. So I'm Matteo from Giskard or Giskard, depending if you are in the UK or in France. And tonight we'll talk about how to test machine learning models, why we need to test them, and how to do that. So what is Giskard? It's a French startup, and we are building the first open source Python library that helps ensuring quality of all kind of machine learning models or artificial intelligence models, if you prefer to call it like this. So what are we going to talk about tonight? The plan, it's basically two big sections, 1 and 2, context and challenges of testing machine learning models. And then we'll see how to practically do that. If we have time, I will make a short demo of our library, of our software, and we'll wrap up for the conclusion. So let's start with the context of testing machine learning models. So safety, reliability, and general quality is something that is essential in all kind of industries in our modern world. So finance, we do audit. Manufacturing, we have some quality standards. In food, we have labeling, right? And in software, we have a lot of work on testing, unit testing, integration testing, all of this framework to ensure that the product that we ship are safe and reliable. That's not really the case for the AI industry at the moment, right? We have lots of incidents that the AI industry is struggling with. These are old examples. So first one on ethical side is Apple Card. Well, they use some kind of machine learning algorithm to define spending limits. And it turns out that it was giving a different spending limit and credit amount, depending if you were a woman or a man. Let's you guess who would get less. And on this business side, Zillow, they used an algorithm to predict real estate prices, to do some kind of speculation, to buy and sell houses. And turned out there was COVID. Their model was not so well-tuned for this kind of situation, and they just lost massive amount of money because of the wrong predictions of the model. And on the safety side, we have attacks, for example, against self-driving car, where you can trick the car to misunderstand speed limit signs and this kind of indications on the street. And we actually have lots of other examples of these incidents, in particular since the the spreading of ChatGPT and this kind of models. It's impossible to track them down all. And if you want to check that, there is a website which is incidentdatabase.ai, which tries to list all these kind of incidents. To scare you a bit more, I will give a specific example of how things can go wrong. So, and how this can happen to anyone, and in cases that are kind of non-predictable. So take this site as a marketplace online. I guess you know it, right? They integrate some machine learning stuff. For example, if I look for cocktail shaker, they will autocomplete, right? Next word prediction. We saw it in the previous talk. And they also have some nice feature of recommending the customers some similar products, some bundles that are often bought together. So this is a recommender system, a very old school machine learning algorithm. What can go wrong with this kind of system? Right. Worst case, you will be recommending a bad product. Well, it's not such a big issue. except, well, when it starts recommending strange things like poison chemicals to teenagers and bundles them in nice kits, right, of right chemicals to kill yourself. And if you don't know how to do that, it can also recommend you a book on euthanasia to learn more, right? So an apparently easy, simple system can have a very big impact when it gets things wrong. So this has been acknowledged also by regulators and the leaders. So, for example, Ian LeCun, this is chief AI scientist at Meta, or ex-Facebook. He says that explainability is not enough. It's not enough to explain how things did their prediction, but we need to look at actual crash statistics. So we need to understand how these kind of algorithms fail. And well, in Europe, we have this coming regulation, the European AI Act, which creates well, so the obligation of putting in place a quality management systems for applications of AI systems which are considered high risk. So in any case, in any situation where this would have an impact on life of people, for example, so human resources or education, it's considered high risk, and you need to guarantee that it works as it is expected to do. Well, you might say this is for us in the continent, and well, you are in the Midlands, kind of Mercia, you don't care about this kind of European regulation, but actually these kind of problems are also coming to UK. It's recent announcement of this £100 million fund to have an expert task force, and I put my emphasis on the fact that they want safe and reliable models. So what is different with respect to the other industries? Why we don't have this AI quality system in place already? And one of the main problems is that ensuring quality of machine learning models has its own technical challenges, which are not completely solved. On the one hand, we use this to think that the problems with machine learning models were just bad data, and we had to collect more data, better data, and that would solve the problem by itself. I would say nowadays we have understood that we can have clean data and a lot of data and still have bad model that can do wrong predictions. And in particular, the errors, the issues with these systems, they always appear when the system had to deal with some unexpected data, right? Something which was not known, like some change in the statistics, for example, some drift of the statistics. This is what happened, for example, with COVID-19. Right? A lot of statistics, for example, about insurance changed a lot, and models were just trained on a different word, on different statistics. And the second problem of these machine learning models is that it's not possible to test them as we did with traditional software by breaking down in subcomponents and testing each component in isolation, because they are collective system. So they're very strong entanglement of the different components. And they also are not necessarily deterministic, so they can produce different output. For example, ChatGPT, right? It will not always answer in the same way, but it will give there is some randomness in the answer. So we have this kind of combinatorial issues, right? We have quality that depends on data, on the model, on the different components of a system, on the chance. And the third thing that we miss is the evaluation criteria. So, for example, we often evaluate the performance of these algorithms, like how accurate they are. We rarely analyze how robust they are with respect to noise in their input data. And nowadays we can more and more observe problems of security, problems of reliability, problems of unethical behavior. And we don't really know how to measure all of these different impacts. And the last is, of course, the environment. Is it convenient to use these kind of models, or are they too expensive to train in terms of energy costs? So we have a lot of open questions. But there's still something we can do. There's some way of starting at least to test these kind of models. And we can take inspiration from the world of software, where they have established this practice of testing over the last, I would say, decade. And they even have this championship of software testing, like World Cup of software testing. One thing that we do in software is this unit test. Right? Here's little Python code. For example, we have a function that adds numbers. We define the function, and when we try to change our mindset and try to think about a situation where we get a different output from this function, and we just try to check that the thing behaves as we expect it to behave. So, for example, we can check. So in a simple example, add 1 to plus 2 is equal to 3. Now, what happens if I add infinite plus 1? Does it give me the right answer? What if I've tried to do infinite plus minus infinite? This kind of stuff, right? So it's kind of changing the approach to try to find edge cases, try to find examples, counter examples. How do we do that with machine learning models? What everybody does is to just look at what I call the global performance of the model, like accuracy. We check how many correct predictions does the model get out of some test set, like a database that we collected of data that we use to evaluate the model. That's, okay, the starting point. But there are actually a lot of ways this model can just fail, even if they have high accuracy. So I will shortly describe this old but classic article about behavioral testing of, in this case, for NLP models, but I will show you that we can apply this in general for machine learning models. So this paper from 2020 gives, I think, nice inspiration to define how to test models in general. One thing we can do is to do simple functional testing, like in software. For example, in this case, let's say we have a sentiment analysis model. We want to make sure that this sentiment analysis model that takes a text and gives a mood, like it's okay, this text is positive or it has negative sentiment. Let's make sure that it understands negations. Well, we can build some templates. For example, I plus some negation form plus positive verb, and then the object. And we can build, by combining different elements here, we can build samples that we know are always negative, right? They have negative sentiment if we put the negation. We can actually do the same by removing the negation, and we know that this kind of sample will be positive. So we can build a test set of examples and check that our model behaves as we expect it to behave. There's one more interesting approach that we can take, which is metamorphic testing. Let's keep our example on sentiment analysis. I want to ensure that this model is robust. It's reliable, basically. One thing is that we can do is to test for invariance. So we say, okay, under certain perturbation of the input, the prediction must not change. For example, if we add typos to our text, well, the prediction of the model should not change. If this was positive before, it will be positive after we introduce typos. We can test for some kind of gender parity. Let's switch genders when there are, for example, jobs or people mentioned in our message, and check that our model does not penalize one given category. We can extend this to some kind of directional expectation. So perturbation that we know creates a change in the output in a given direction. For example, I know that if I add an adverb like I have an initial phrase which is I like the food. If I add I really like the food, well, positivity of this sentence cannot decrease. It can only increase. And we can do the opposite, of course. If I add at the end of a sentence, I hate you, for something which was already negative, it's not going to turn positive. And as I was saying, we can actually apply this kind of reasoning to almost any kind of machine learning model. For NLP, that's what I just showed. We can add types, we can replace words, this kind of tricks. For images, we can add noise and check that our predictions are okay. And we can blur, we can do other kind of...
Matteo, sorry, just 1 second. I think we lost the projector because it went to sleep.
Whoops.
But now it's starting that.
Just
Okay, where did you go?
we're just starting the project. Yes, you're back online.
It's good. Okay, so I don't know exactly where you lost me, but I was saying that this metamorphic testing can be applied
That's perfect.
to almost any kind of model. We've done it with NLP, but we can use it with images. We just do some kind of modification, perturbation of images, and check where it's kind of predictions. We can do it with numerical data. We can just change a bit the values, adding noise, this kind of stuff. We can do it categories. We can change categories and, for example, expect that we have a certain variation in the output of the model. Then the hard thing, fairness. Okay, testing fairness of machine learning models is much harder, right, than just testing their if they're robust, if they behave as we expect in terms of quantitative measures. The co-founder of Giskard, Jean-Marie, actually wrote a review on this, on how difficult it is and what are the possibilities. But with its limits, we can, in any case, try to measure something. Whoops. I think we lost the slides.
Yeah, that's cool.
Don't know what happened. Let me try to.
I was changing the volume. It's probably my fault.
Let me try to get it back.
Yes.
Yes, I just need to skip. Where were they? Yeah, okay, we're here. So testing for fairness metrics. One example of this top-down approach, we want to ensure our model is not discriminating people. One kind of metric that we can use is disparate impact, which works like it tries to evaluate basically if a decision that the model takes has some kind of adverse effect on a protected group. So you need to define a protected group. It could be seniors, could be women, could be Black people. Right? This you need to know by the bias that we have in society what you consider as a protected group. And let's say you have a classification model that has some positive output, y equals 1, and negative output, y equals 0. What you can do is to take the ratio between the percentage of positive predictions that you get when the data belongs to the protected population versus the ratio of positive predictions for the inputs, the people basically that do not belong to the protected population. So there's a rule of thumb that is to put a threshold at 80%, and if disparate impact is greater than 80%, well, you know that you have a problem, right? this metric is not perfect. Of course, it's not enough to say that your machine learning model it's not discriminating, but it's one possible starting point. The comparison of this approach is to have a bottom-up approach and to collect human feedback, and that's where actually Giskard enters into play. We provide an actual interface that allows you to inspect the model, its predictions, and to add some feedback related to some specific features. For example, here, foreign worker, if we think that there is a potential bias here, we can just annotate and let the data scientists working on this model know that there could be some ethical problem. And the last thing that I want to mention is underperforming data slices, which is something that it's often neglected. When we measure performances of machine learning models, we often measure that as a global average of something. And it's not always the correct way to evaluate the behavior of the model. Because the model can be very accurate on average, but still not accurate on some specific subpopulations. So for example, practical example, you have CV screening model, which has very low false negative rate when it looks at CV of men, and it has very high false negative rate for the other genders. This is clearly a problem, right? Even if on average, the model is performing well. Same, and this is a real world example that we found. Sentiment analysis model that performs well on average, but when the text contains the word COVID-19, doesn't really know how to classify that, right? So these are problems which are specific to subpopulations. So you need to take into account this and you need to test this. So if you have a couple of minutes, I will try to make a quick demo to show what we actually built at Giskard. So you should see my screen with code, and I will show you just the simplest model of all. It's yeah. Do you hear me well?
Yes.
Okay. Simplest model that you do when starting career in data science is the Titanic dataset. You have a list of passengers of Titanic, and you want to predict whether they survived or not based on their sex, where they embarked, in which class they were traveling in. So you can train simple classifier in Python with scikit-learn. You do all your nice things. You measure your performance. Well, it's not perfect, but well, okay, decent performance. And this is where Giskard can help you. What you can do is to wrap your model so that we know what kind of model it is, wrap your data set so that we know what you're trying to predict, and launch an automatic scan for problems in your model. So we'll try automatically to find, in this case, subpopulation where you have problems in your data. So this will just launch a bunch of automatic tests. It's meta machine learning, so it's machine learning models to try to detect problems on other machine learning models. And well, what you get at the end, it's something like this. And we have a series of issues, 9 issues in this case. It found that our model performs badly when the name of a passenger contains Mr., and it performs badly when the sex equals male. So you have examples of rows in your dataset that were wrongly predicted. It has detected that we have a robustness problem when we change the case. So we transform to lowercase the feature embarked, which is just the name of the class where we embarked from. It finds spurious correlations between our predictions and some gender in this case. Right. So we kind of try to do the work for you. And what you can do next, well, is to create test suites based on this. And we can also do that automatically. You just need to take your results and generate a test suite, and you can actually upload it to a UI where you get something like this, which prepares a series of tests that you need to pass. So you need to improve your model to pass this kind of tests. You can run them. You can select a new model. You can check if you improved on something. You can compare models. And what you can actually do is also to edit these test suites. And we have a catalog of tests pre-made. For example, we saw this before, disparate impact. So you can have already a test ready for you. You just select the model, the dataset. What is your protected population? For example, we can say our protected population is passengers traveling in third class. Let's see if I find it. Okay, P class is equal to 3. And the unprotected population, well, it just all the rest of the people. Positive outcome is you survived. Let's check. And well, test failed. Yeah, 40% disparate impact. So you can kind of access all this kind of information in an easy way and design tests for your models and test them as you update them. Okay, let's go back to our presentation for the conclusions. Let me skip this, which we saw. So summary, take-home messages from this. Learn from the past incidents, right? Showing you the incident database.ai. It's a good resource to know how these systems can fail. So try to think with this, what I call the versatile mindset about what can be wrong with your models, right? Think about recommender system of Amazon trying to suggest poison to people. So there are things that can go wrong. Take inspiration from a past incident, try to project what can go wrong in your system. And finally, test, debug, and repeat, and do it constantly on your model to ensure that they are behaving as you think they should behave. And well, last point, start our project on GitHub if you want. It will help us like spread the word about testing machine learning models. That's it. Thank you very much, and I'm glad to take questions if you have some.
Hi, thank you. Yes, you missed the applause, but there was one. Any questions? Yes, there are a few questions here. Just 1 second. Can you hear us with this?
Yeah, I don't hear very well, but I do hear you.
Can you hear this?
Yeah.
Loud? Okay.
Oh, currently compatible with PyTorch, or is it just sklearn models that it's working with right now?
We do support almost everything. PyTorch, scikit-learn, LightGBM, Hugging Face. We recently integrated with LangChain to test LLMs, TensorFlow. Yeah. And if we are not compatible, we can actually quite easily write your own wrapper class and just put whatever framework you like.
Okay, yeah. Cool. Thank you.
Thank you so much. First of all, it has been highly informing. It was really. So let's say I have a generative model that is producing undesired output. Let's say I have a language model that's recommending people to commit suicide, right? Is there a mechanism in Giskard to capture those, let's say, undesirable outputs and to flag them?
For language models, generative models, we have an alpha version for generative models, and more is coming soon in the next weeks. So we do some detection of harmful generation. We try to do some modification of the prompts to induce the model to generate harmful content, and we check that. We have a bunch of other checks that are currently in alpha, so you can try it out, and more coming in the next week. So yeah.
All right, thank you so much. Appreciate it.
We had a presentation from Giskard about a year and a half ago, and this was really, really incredible timing when they launched the product. Alex, their co-founder, has been on a mission. I've heard that they recently went on the AI talks with the President Macron. Yeah, I think the project is really going places. You have an open GitHub repo, sort of, yes, sorry, it's linked there.
Yeah.
I can put it in the chat, or if somebody can put it in the chat. Or,
Yeah, I can type in the chat, I mean, website.
Cool. Okay. Any last questions? Yeah, Ryan.
Thank you. That was a really cool talk. Do all of the kind of like heuristics and other tests run inside of the Giskard platform? Or is it a model that you can, or is it like a set of heuristics that you can license out and then self-run? Or is it all dependent on the Giskard AI platform at the moment?
Well, you can run them in the platform with the UI that I showed you, but you can actually just write your own code and import these functions that we expose. I can quickly show. Let me stop this, and you have a series of tests that you can reuse. So, for example, we shown disparate impact. So these are just Python function, but you can import from our software library and use wherever you want. Same principle, you are quite free and using this kind of pre-made tests. And you can also add your own tests. You can clearly define your own testing function and take advantage of the pre-built logic that we provide.
Thank you very much.
You're welcome.